Okay, so in the first one, we've got the exponent law. X to the A times x to the b is x to the a plus b. When we multiply expressions, we add the exponents. So if we're multiplying the expressions, we're going to add the exponents. We have the same base in each one, so what will the exponent be?
5.
X to the 5. So here in this one, we've got x to the 6 times x to the something is equal to x to the 10. What must the something be? 4. So a equals 4. Have a go at this now. Have a go at these ones now. C, D, and E for yourself for a minute. Try and write it down. Can you log into the master? All right, it's time.
Also, I think you're still recording.
Yeah, that's no problem. So I can pause it a minute. Okay, let's have a look at our answers. So for C, this is going to give us t to the what?
7.
T to the 7. Excellent. What about for D?
53.
It's not going to be 53.
47.
Why 47?
Because negative 3 plus 50.
Negative 3 plus 50. You can think of this as 50 minus negative 3 as well.
See the new level. Minus
Yeah, so I figured, sorry.
50 minus negative 3.
Yeah, minus 3 plus 50 or 50 minus 3. This will give us our answer. What about a to the x times a to the y?
A. A x plus
A.
A.
A to the power of x minus
A plus.
A to the power of x plus y.
Yay! So this one is a to the x plus y. Remember, when we do this multiplication, where we have the same base, we add the exponents. And that's rule number 1. That's rule number 1. Okay, let's do another one. Rule number 2, if we look up here. I like yellow. We look here. Here we've got a to the x to the a divided by x to the b. And in this case, when it's division, we subtract the exponents. So I'm going to do the first one for us. If we have n to the 5 divided by n to the 3, that's n to the 5 minus 3. Adam? N to the 2. Let's have a look in B. Let's have a look in B. How are we going to do this? That's a 4 and that's a 12. How are we going to do this? I mean, a to the 4 minus 12. Good. What will that give us? Negative 8. Now look here. We're asked to answer using positive exponents. So we have to refer back to that rule that we've seen previously.
V minus A.
The rule is x to the minus n is equal to 1 over x to the n. So we can make an exponent positive by moving it through the quotient, either up or down. So for this one, our answer is going to be 1 over a to the 8. Now the exponent is positive. You need to practice the IXLs on negative exponent. That was from a week ago. Okay, C. Okay, want to do this one first? Here are exponent in these generalized ones.
A to the power of x minus 1.
A to the power of x minus y. Excellent. All right. So now it gets a little bit more complicated. I might use a different technique here for this one. So with D, I'm going to look at each one individually. So here, what is the difference between 3 and 10?
7.
7. Which one of these two is the bigger one? The one at the top or the bottom? So that will stay in the bottom and be a 7. What about the C's? What's the difference between these two? 2. And which is the bigger one, the top or the bottom? Top. Mally, do you want to follow the lecture instead of starting the IXLs? So we're going to get C to the 2. Let's try that technique here for this last one. Try it for yourself for a minute. All right. So for this one, it's a little bit more complicated than D. D was quite easy to do. I could just sort of look at the differences and decide where it goes. But when I'm looking at this, I get a bit confused. So I'm going to go back to first principles and use this technique like I did in B. So I'm going to take x to the minus 4 minus, and then I've got negative 3. Y to the 3 minus, and then I've got negative 5. So just putting the two numbers like this, I always put a bracket around it when it's negative, and then subtracting them. So this minus sign is the division symbol. This minus sign there is the division symbol. The other ones are negative from the numbers in the question. So I can simplify. This minus minus becomes plus, doesn't it? So this is x to the minus 4 plus 3. Y to the 3 plus 5. This gives x to the minus 1, y to the 8. So our answer with positive exponents is to move the x down. We get y to the 8 over x. This will take a little bit of time to practice, so I'm going through it fairly quickly today. I'm recording it for you so you can look at it again later as you practice with the IXLs. The first few IXLs you'll gain confidence. It will get more complicated towards the end, so you won't grasp what I'm talking about here entirely until you've practiced it. So don't worry now. Watch the video again later, work with the IXL exercise, and when you completed that work, then you will have a better understanding. Okay.
Why is the minus 1 and the x minus 1?
We're using this rule. Here. And when it's a positive one, we don't show it, we just write x. You could see this as being x to the 1. So it's changed from the numerator of the quotient into the denominator by taking away the minus sign. You can always change it up and down. If you have a negative 1 in the bottom, you move it to the top and make it positive. You just change the place in the quotient between the numerator and the denominator, and you change the sign. Right, so we have another rule here. So x to the 3 times x to the 3, what's that going to be?
36.
Yeah, so this is the first rule. We're doing x to the 3 plus 3, which is x to the 6. Now the second one, we need to use the power law. So this one, the third exponent law, is the power law. And this is where we have x to the a all raised to the b. So when you take an exponent of an exponent, you multiply. When you take the exponent of an exponent, you multiply. So this one becomes x to the 3 times 2, which is x to the 6. Now these two link. These two questions link. We have the same answer. Notice we have the same answer for both questions. How do they link? What's another way of writing x to the 3 times x to the 3 at the back side?
Yeah, it would be x to the 3 squared.
Yeah, so it's x to the 3 squared. So anything times by itself, that would be squared. So if we were to write 4 times 4, that would be 4 squared. So in this case, where we have x to the 3 times x to the 3, that's x to the 3 squared. It's the same. And what we see from this one is that when we're multiplying, then we add the exponents, we get 6. So this has to produce the same results when we square it, because these are both the same number. This number here and this number here are identical. Anything times by itself is the same as squaring that number. So let's use the power law for number 6 and 7. Sorry, numbers, don't know where I got those numbers from. For C and D. What's the power law for C? Have a go at it. Have a go at it. Give other people time to have a go at it. Try and write it down something on your piece of paper, Raphael. All right. So x to the 6 to the 5. What's that going to be? Let me take Hannah. We can't say x30. X30 is this. X to the power of 30. X to the power of 30. Right, the last one. The last one. We have another law that we can use a little bit here. If we have a times b to the x, that's a to the x, b to the x. I can apply that rule here on this one to give me n to the 3 to the 3, n to the 5 to the 3. That's going to give me n to the 9 times n to the 15, which is n to the 9 plus 15, which is n to the 24. But I can tackle the same question in a completely different way.
Or you do n3 to the power of 3 plus 5.
So we can use the product law for indices first by adding these two together. And what does that give us, Marie? N to the a. And then we use the power law, which gives us n to the 8 times 3. And what would the answer be? N to the 24. Okay, that's it